Hi guys. Um, just looking at this week in science, we are going to be watching this video and taking notes on how soil is formed. And then you'll be watching a Bill Nye video and answering some questions on that. You can print the questions from home if you want, but I need you to submit those on a form. I've put a link on my website, so you can do it either way, or you can do it both ways. You can answer the questions on the paper and then submit it through forms if you want to do that. And that is for a grade. We'll have 2 grades this week. On Wednesday at 12 o'clock, we have a live lab with Miss Summer. She is going to be showing us how to make some layers of soil using some fun things at home, and you'll get to do that. And then you're going to make a soil model and write a recipe of how you would make the soil model. And then we're going to submit that on Flipgrid, and that is also for a grade. So 2 grades this week. Make sure that you check student view. You should have 2 grades, and those 2 grades came from the quizzes, one from 2 weeks ago and one from last week. So make sure that you have grades for both of those. All right, let's get started. All right, so you'll want to get out your soil formation notes that I had a link to. We're going to be filling those in as we go through the soil formation video. So soil is very important to our lives. We walk on grass that's rooted in soil. Foods we eat need soil to grow. But what exactly is soil and how is it formed? Those are the questions we're going to be answering as we go through this. Okay, our standard is that you will plan and carry out an investigation to provide evidence that soil is composed of layers of weathered rock and decomposed organic material. And you're actually going to be doing your own investigation on Wednesday, so make sure you join us for Miss Summers' presentation. It's at noon on Wednesday, so mark your calendars. Right, your ticket out the virtual door. Hopefully by the end of this lesson you will be able to answer how does soil form, what are the 5 soil horizons and what type of soil is in each one, and also what are the 5 properties of soil. So a lot that you need to learn in this lesson. So what causes soil to form? Let's start with defining soil. So scientists define soil as a loose mixture of small rock fragments, organic matter, water, and air that can support the growth of vegetation. So how does it form? Well, it starts by weathering of a parent rock. So weathering breaks down a parent rock into smaller and smaller pieces. And these pieces eventually become very small particles that are mixed in with organic matter to form the soil. The process of soil formation can take a very long time, and the amount of time it takes depends on many factors, which we'll get to in a little bit. Okay, it's also formed from the decomposition and mixing of living things. So there's little microorganisms, some are bacteria, some are fungi, and they decompose things that live in the soil. So they perform important tasks of breaking down things that die in nature and kind of making them part of the soil. It makes the soil a lot more fertile. And you can see in this picture how it's very dark. That's what we call humus, and that is the remains of decayed organic matter. And it's usually found in the topsoil. We'll get into more of that in just a few minutes. But plants use all these nutrients and things that are left in the soil. It helps them grow. And we have large animals like earthworms and moles that live in the soil and help kind of break it up and get air down into the soil. So it's pretty interesting how soil is formed and how it keeps getting formed year after year. All right, so let's talk about the weathering of a parent rock. So if we look at the first picture here, you can see that it's all rock. Rain is falling. You've got these cracks starting to develop. Water will seep down in there, and it'll eventually start to break up that parent rock into smaller pieces. When we look at step 2, you can see that this parent rock is now broken into a bunch of pieces. The heavier ones are starting to sink because of gravity. We've got some things on the surface that have died. That's becoming the organic matter. And then it's starting to get mixed all in here. In step 3, we've got bedrock at the bottom. That was our parent rock. Then we've got the sea horizon, which is our parent material. It's just broken up. And then we've got mineral particles starting to form, and then we've got more and more organic matter. You can see that the particles are getting smaller and smaller as we move up the layers. And then finally, for step 4, that's where we have the well-developed soil. If you are going to be a farmer, this is the type of soil that you want to have. You want to have the parent material far down, then you want your mineral particles and your organic matter at the top. This is what's going to grow the best plants. All right, so let's talk about decomposition and mixing by living things. So we have a lot of microorganisms in our soil. Just to give you an idea, if you took 1 spoonful of soil, there would be about 1 million microorganisms in that. So we have a ton of them. And those little tiny microscopic bacteria and fungi, they break down the remains of dead plants and animals. And those are actually what help keep our soil fertile. And that decayed organic matter is called humus, and that is what farmers love. That's the best thing to grow plants in. And if you have any gardens or anything in your house, a lot of times you'll probably go to Home Depot and buy some of this, because in Georgia we have clay and it doesn't really do a good job of growing things. We usually have to add something to it. So that decayed organic matter that is called humus has lots of nutrients that plants need to grow. And larger animals like worms and moles, when they burrow or make tunnels, they loosen the soil, and that helps bring oxygen down into the soil, which is also something that plants need. And it also helps the soil to drain better once it has some ways to seep down. That helps it drain so that plants aren't just sitting there in water. They wouldn't survive if they just sat in water. They need water, but they need it to drain away. All right, so how long does it take for soil to form? Well, this is not an easy question to answer because it depends on quite a few different things. So there are 4 factors that determine how long it will take. So the first type is, what kind of rock is it? So we know that softer rocks are going to weather and break down a lot faster than a harder rock. It also depends on the climate. If the climate is warm and wet, it's going to create soil faster. So we know that probably in Florida, they make a lot of soil very quickly versus somewhere up in Canada where it's not warm and wet. The third factor is the typography. Soil develops faster in flat areas with less erosion. And the fourth factor is plants and animals. So if there aren't a lot of plants and animals that grow there, they can't decay and become part of the soil. So there's more plant and animal life the more plant animal life there is, the faster that soil will develop, and it will begin that mixing process and the decomposing. The microorganisms will help make the humus. So it depends on basically, you know, do things already grow there? Do they not? And if they do, it's faster. If there aren't any plants and animals there, it takes much longer to make the soil. Right. Soil horizons and soil profile. So soil horizons are the different layers that can be in a soil. And a soil profile is specific to a certain place. So if I dig down deep in my yard, if I go deep enough, I'm going to see that there are different layers. And what I have in my yard is going to be different than what my parents have in Florida or what my cousin has in Colorado. Soil profiles are different in different places because it depends on, you know, what's there to make the soil. So if we look at the different horizons, most soil have the A, B, and C horizon. Some soil profiles have the O horizon, which we'll start with. The O stands for organic, which is either humus or organic matter, such as decomposing leaves, and it's thin in some soils and it's thick in others. It just depends on where it's from. And sometimes there is no O horizon in a soil profile. So then we move on to the A horizon, which is topsoil. You can see that over here. That's very rich in organic matter. It's typically a dark color. And this is also called the zone of leaching. Leaching means things are moving down. If you have a garden, you've probably had to go and purchase some topsoil because the Georgia clay is not really good to grow a garden in. You've got to mix some things with it. In some soil profiles between A and B, if you look over here, there's also an alluviated horizon, and that's made of clay, minerals, and organic matter that are resistant materials, meaning they aren't leaching as quickly. And it's missing in some soils, but it's often found in older soils, like especially out in the forest where it doesn't get disturbed. You'll find that alluviated horizon. So if we move on to B horizon, that's what we call the subsoil. It's also called the zone of accumulation, and it may contain soluble minerals such as calcite in arid climates, and this is rich in minerals that have leached or moved down from the A or the E horizon if there was an E horizon there. Then we get down to the C horizon, and that's the weathered bedrock that was broken down. It's not solid anymore, it's in chunks, and it lies below the soil profile. And then finally we get to the R horizon where we have that solid bedrock. It's just a big mass of rock. It could be granite, it could be basalt, it could be quartzite, limestone, sandstone, whatever the parent rock was. And if it's close enough to the surface to weather, you won't have any of this soil, and it's always located underneath the C horizon. Right. As I said, soil is different depending on where you are, so we're going to take a look at some properties of soil. So the first one is soil texture. So that means the size of the particle. So sand is the largest, and that's from 0.05 of a millimeter to 2 millimeter. You can kind of see on this chart, we've got gravel, and then we've got sand, which is kind of what you'd see at the beach. Then we've got silt, is even smaller, and then clay, which is what we have here in Georgia, is almost invisible to see one tiny particle of clay. It's very, very small, less than 2/1000ths of a millimeter. So I don't think we could even see that with our eyes. So the first property of soil is its texture. Another property of soil is its color. So we know soil can be many different colors. It can be black, brown, red, orange, yellow, gray, and even white. And the color is created by the minerals and the amounts of organic matter in the soil. Most soils are a mixture of colors. I know I was planting some plants since we've been off of school, and I noticed the top layer of my yard is kind of black, and then once I get down deeper it's red. So mine is a mixture of colors, but I can definitely see the layers there. And it also, another property is the chemistry. So it depends on the pH of the soil. The pH stands for potential hydrogen, and you'll learn about that when you get into chemistry, but basically it tells how acidic the soil is or how basic. It's a range from basic to acidic, and that determines what plants will grow there. Sometimes we have to add different things to our soil to change the pH, because some plants like a certain level of pH. So Home Depot sells a bunch of things that you can put into your soil that will actually change the pH. Another property of soil is the pore space. So what that means is the spaces that are between the soil particles. So we know that in Georgia, our clay particles are so small and compacted, we kind of have really no space between the particles. That's why clay doesn't drain. But when you get into more sandy soil, there's a lot more space between those particles, so things can drain easier. So the more space it has, the more oxygen and the more water can move through it, which makes it better for plant growth. Soil fertility, that means how well soil can support plant growth. And that's affected by the climate, the amount of humus, the minerals that are in the soil, the nutrients, and the topography. Fertile soils are found in areas with moderate rainfall and temperature. And that's just common sense. We know that plants need water to grow, and in order to make soil, there needs to be plants there because they need to die and decompose and help make that top layer of humus. So it's kind of, a cycle. If there's no plants growing there, you're not going to have good soil, so you can't really grow anything there. So it kind of is common sense there. All right, it's time for your ticket out the virtual door. So number 1 was, how does soil form? Number 2, what are the 5 soil horizons and what type of soil is in each horizon? And then what are the 5 properties of soil? I hope you know those.